Good morning. Our topic for the business analytics poster making competition this year is time series prediction to understand the behavior of the IPO stock market, presented by Reeha, Naaz and Jade Zhang. We have used the stock IPO information and the results dataset available on Kaggle to perform time series prediction. Predicting stock prices is one of the popular old business problems which still does not have a definite solution. While several methodologies were developed using technology with time, which are used by various industries to invest in stocks, it does not always work well. To understand the trends in trading stocks in a better manner, apart from performing traditional time series analysis, we also want to utilize this data to the maximum as it contains an extensive range of features to play around and make meaningful interpretations in how exactly they influence US stock market. Our problem statement focuses on three key issues. How does the traditional method work for IPO stock price data forecasting? Is it possible to combine predicted value we obtain and the other information to generate more accurate prediction? What features contribute to stock prices in the US market? The data contains information about the US stocks and related information of 3,762 companies that were publicly traded on 1st January 2018. The historical prices consist of the open value, close value, lowest value, highest value, and volume for 261 days, and the related information includes the stock symbol, industry, revenue, and so on.
The original data is obtained from Kaggle. It includes around 16,000 columns and 30,000 rows, representing different stocks' historical prices and other descriptive information of companies such as SIF score, monthly trend, and so on. We first formatted data by converting strings that represent numerical values to int or float, and separated the messy dataset to several different data frames, such as close prices, descriptive information, and so on, for future use. We then deleted the column that contained too many missing values or contained useless features, filled the missing values, and performed hard encoding to make the categorized variables dummy variables. We first used the ARIMA model for the one-day ahead price prediction. The stationary check using Dickey-Fuller test was introduced first, and since the p-value was too high, we took log transformation and subtract exponentially weighted moving average to satisfy the requirement for stationary. We also took a result from decomposition that removed trend and seasonality. Then we performed tests again and obtained low p-values. The graph shows an example of stocks. The results of prediction are recorded for the future analysis. Then we combine the one-day predict price we obtained from last step and other features about stocks to predict both the price and trend. For price prediction, we use random forest, support vector machine, decision tree, and XGBoost. Then we selected the model with the best performance to tune the parameters, perform PCA, and also cross-validation. We did a similar process for trend prediction, except this time is classification problem instead of regression problem.
In this visualization, we can see that highest revenues have been generated by Ecopetrol, Grupo Aval, LG Display, KB Financial Group, KT Corporation, Shinyan Financial Group, and Wells Fargo. The further plots will help us understand the behavior of companies that generate high revenue in the stock market. Let's try to further understand the behavior of these organizations. Let's take a look at this plot. Here we can observe the pattern of open price, close price, high price and low price on day 1 for the organizations with highest revenues. We can see that all their prices are more or less the same except for EC, which kept its open day 1 price pretty low. Apart from that, we could observe that this could be one of the factors that helps the company generate a high revenue. But this is not enough information. Let's explore further through the next plot. This is a bubble plot which talks about upper and lower trends of various companies at the stock market. Here the light blue color indicates a lower trend and the dark blue indicates an upper trend. We can see that AG Mortgage Investment, whose abbreviation is MITT, is among those companies with a positive trend which has highest true price value. But AG Mortgage Investments is not among those companies with highest revenue. Let's make further plots to understand what could be the factors. Red color here indicates negative trend and green indicates positive trend, and darker the color, higher is the respective negative or positive impact. Even here, AG Mortgage Investment has way higher trend value for both 3 months and 6 month market trend compared to other companies, which cannot be ignored since Ecopetrol, that is EC, has a high negative trend value and still managed to make good revenue. To further analyze this behavior, these companies are plotted based on the trend value, profitable value, and the performance compared to S&P 500 index. The value on top of each bar indicates market capitalization, that is the total value of the company's outstanding shares. Again, AG Mortgage Investment had higher S&P index than the rest of the companies for most days of the year. Based on these plots, a possible reason for companies like AG Mortgage Investments not to earn a high revenue is probably due to stock splitting. Companies often split the stocks to sell for a lower price while maintaining the total values of the shares. This is done in order to attract more investors to buy the company's stocks, that is, increasing its liquidity.
Based on our study, we would like to conclude that the traditional statistical method ARIMA actually works well for the price prediction. As the graphs of some examples show, the RMSE is pretty low and the curve fits well. Our combined method for trend prediction did not perform well. All the algorithms we tried generated similar accuracy around 69%. We assume it might be caused by several reasons, including ARIMA might be able to generate values close to the true value but not trend, or maybe the trend is not really predictable in our case using our method. Our combined method for price prediction using tree methods performed well regarding R-square. Others did not. The performance of algorithms are extremely different from each other. The R-square of random forest and decision tree model are very high, but in the case of SVC is even lower than 0, means that the regression analysis did even worse than just using horizontal lines through the mean value. The reasons behind this phenomenon will be considered in the future research by adjusting the features and using more evaluation criteria such as RMSE. For trend prediction, there is no particular features are selected by algorithms. The most important features for regression selected by the random forest feature selection are market trend, safe score, the price of the most recent day, and the number of days of profit. We have some suggestions for future improvements. First, due to the limitation of the computational power, we were not able to complete every thought we had. More methods for time series prediction, such as RNN, can be used to obtain more precise results. The same for the evaluation criteria. It can be expanded once the wider range of data are computed and analyzed. Also, the reasons why our methods had unsatisfying results could be thoroughly analyzed in the future to further justify our assumption and find more suitable methods. That's all. Thank you.